Some of the worst boat engines ever made came from companies everyone thought were bulletproof. You'd think marine engines, especially from trusted brands, would be the last thing to fail on the water. Yet somehow they ended up failing to power thousands of boats, leaving people stranded, smoking, and staring into the abyss of their wallets. The real kicker, most of them looked flawless on paper, until they started blowing head gaskets and wrecking weekends. What killed them off might not be what you think. It wasn't just bad luck or poor maintenance. You heard that right. These engines were doomed before they even hit the water. And the reason why? Well, watch ahead, as this might change how you shop for your next inboard forever. The Chrysler 440 was a legendary big block V8 in muscle cars, but in boats, it turned into a mechanical headache. Chrysler Marine marinized the 7.2-liter engine in the 1970s, hoping to compete with MerCruiser and Volvo Penta. On paper, the 440 promised serious torque, but once it hit the water, problems piled up. Its cast-iron block and heads made it extremely heavy, which affected hull balance and efficiency. But the real killer was heat. Marine cooling systems struggled to keep the 440's massive thermal load in check, especially in salt water. Overheating wasn't the only issue. The engine's Presto-Light ignition system was notoriously unreliable, frequently failing under heat or vibration. Timing chain slop was also common, leading to poor timing, misfires, and in worst cases, piston-to-valve contact. For an engine that looked bulletproof, it turned out to be fragile under marine stress. Today, parts are hard to find, and many mechanics advise against rebuilding one unless you're restoring a period-correct showpiece. Most owners repowered with GM or Ford small blocks to avoid endless breakdowns. The Westerbeke W30 was marketed as a compact, reliable diesel for sailboats and cruisers. Built around the British Perkins 491 block, it had the bones of a decent engine, but marine application exposed all its weaknesses. Rated at around 30 horsepower, the W30 was often pushed to its limits, especially in boats that were heavier than ideal for its output. Add in hot weather or extra accessory loads and the engine began to struggle. Cooling was one of its biggest flaws. The narrow, raw water passages in the heat exchanger would scale up in saltwater environments, causing temperatures to spike. Many owners experienced chronic overheating, especially when the impeller wore out, which happened more often than it should have. If left unchecked, this led to cracked cylinder heads or warped valve seats. The exhaust elbow was another weak point. It corroded internally and restricted flow, worsening the heat problem. The mechanical fuel system added further frustration. If injector timing was slightly off, performance would tank. Combined with noisy operation and hard cold starts, the W30 became more burden than benefit. If this list is hitting close to home, tap subscribe. And don't go anywhere, because the last engine looks modern, sounds reliable, but it's ruining boats right now. You'll want to know before it ruins yours. The Volvo Penta AQ170 was based on Volvo's B30 car engine, a 3-liter inline-6 pulled from the Volvo 164 sedan. It made around 170 horsepower and was fitted to boats throughout the late 60s and early 70s. While it ran smoothly when new, its long-term marine performance left much to be desired. The cooling system in particular was inadequate, especially for saltwater. Corrosion and scale would build up fast in the narrow internal passages, often leading to overheating and even cracked cylinder heads. The rear cylinders ran noticeably hotter than the front, which over time caused warped heads and uneven compression. Many owners reported issues with blown head gaskets and coolant loss. The dual carburetor setup, while powerful, was hard to tune and often ran rich, further straining the engine under load. Once reliability declined, the AQ170 became a burden rather than a benefit. Replacement parts became a major issue. The marine-specific components, like the intake, exhaust manifolds, and water pump, were only made in limited numbers. Today, finding these parts is expensive and time-consuming, making the AQ170 a poor candidate for restoration. The MerCruiser 470 is one of the most notorious marine engines Mercury ever built. Designed between 1976 and 1989, this 3.7-litre four-cylinder was based on a cut-down Ford 460 V8 block. On paper, it sounded great, compact, lightweight, and offering around 170 horsepower, but in reality, it was a mechanical time bomb. The biggest issue: the combination of an aluminium head on a cast-iron block, which gave galvanic corrosion, leading to blown head gaskets and coolant loss. But that wasn't the only flaw. The 470's plastic camshaft gear was prone to sudden failure. When it stripped, the engine lost timing instantly, often damaging valves and pistons. Its integrated alternator, driven off the camshaft, was also fragile and hard to replace. Add in constant ignition coil failures and a weak water pump setup, and the 470 became a boat owner's worst nightmare. Today, many mechanics flat out refuse to work on them. Owners who haven't already swapped them out for small block Chevys usually keep a spare engine or a tow rope on standby. Yes, BMW once built marine diesel engines, and the D190 is a perfect example of how even German engineering can fail offshore. Based on BMW's 3.4-litre six-cylinder automotive block, the D190 was marinized in the 1980s and marketed as a high-performance diesel for cruisers and sport boats. But while it had power, it came with complexity, fragility, and sky-high maintenance costs. The Bosch mechanical injection system was extremely sensitive to fuel quality. Any water or contaminants could destroy injectors or disrupt timing. The D190 also suffered from head gasket failures and overheating, especially in saltwater environments where the heat exchanger and coolant pathways would scale up rapidly. Exhaust manifold corrosion was a common killer, often leading to warped heads or cracked casings. Today, parts are almost impossible to find. BMW exited the marine diesel market, leaving owners with orphaned engines. Mechanics who do work on them often charge extra due to poor access, specialized tools, and limited documentation. If you find a used boat with a D190 on board, consider it a major red flag. The OMC 800 stringer drive system paired with the Ford 302 V8 seemed like a solid match for mid-sized runabouts and cruisers. The Ford 302 was a proven automotive engine, as the OMC 800 outdrive was touted as innovative. But in practice, this combo caused endless frustration for boat owners and mechanics alike. While the engine had decent torque, the cooling system was poorly marinized, leading to frequent overheating and cracked exhaust manifolds, especially in saltwater environments. The real headache, however, was the OMC stringer drive unit. It used a unique hydraulic tilt and splined shaft steering setup that made engine alignment critical, and virtually impossible to keep perfect. As mounts shifted, the drive shaft would bind or misalign, wearing out gears and seals prematurely. Once the upper gear case failed, owners were often faced with full drive replacement due to obsolete parts. On top of all that, the electric shift system used on some models was unreliable and prone to solenoid failures. Today, boats with this setup are often sold cheap for a reason. Most owners repower or walk away. The Bukh DV36ME was a 36-horsepower marine diesel engine intended for sailboats and small commercial vessels. While Bukh engines are often praised for their simplicity and use in lifeboats, the DV36ME had a range of mechanical and reliability issues that made it one of the brand's weakest offerings. It was underpowered for many of the boats it was installed in and produced heavy vibration at idle and cruising RPMs, causing discomfort and stress on mounts and couplings. A major flaw was the crankshaft's tendency to fail under load. Several DM36ME units experienced cracked or broken crankshafts, often without much warning. Bukh quietly updated the design in later models, but the damage to reputation was done. Fuel injector issues were also common. The Bosch mechanical pump was overly sensitive to wear, leading to poor atomization, incomplete combustion, and constant black smoke from the exhaust. Service was another issue. The DV36ME shared few parts with other engines, and Bukh replacement components were expensive and sometimes backordered for months. Most owners today opt for repowering rather than overhauling these engines. If you're finding this helpful, go ahead and subscribe, and keep watching. These engines ahead with problems way worse than anything you've seen so far. One of them is still being sold today. The Perkins T6.354 was a well-respected naturally aspirated diesel. But when Perkins added a turbocharger and released the T6.354, things went south. This 5.8-litre inline-six was intended for heavier-duty marine use, but the turbocharging system was poorly matched to the engine's fuel delivery. It created uneven combustion, ran hot under load, and significantly reduced reliability compared to its non-turbo sibling. One of the most common complaints was cracked cylinder heads and burnt valves. Exhaust gas temperatures were high, especially under full throttle, and cooling systems often couldn't keep up. The T6.354 also suffered from turbo oil seal failures, which led to oil getting sucked into the intake, causing white smoke and loss of power. In saltwater environments, the heat exchanger and manifolds degraded quickly. While parts for the standard 6.354 are still widely available, turbo-specific components like the turbine housing, exhaust elbows, and injection tweaks are scarce and expensive. Many marine mechanics recommend derating the engine or switching back to the non-turbo version entirely. For an engine that promised power, the T6.354 delivered more problems than propulsion. The Yanmar 3QM30 was a 3-cylinder, 30-horsepower diesel engine designed primarily for sailboats. While Yanmar is known for building durable marine engines, the 3QM30 stands out as an exception. It was loud, vibrated heavily, and often felt underpowered for boats in the 30 to 36-foot range. The engine had a raw water cooling system that struggled in saltwater environments. Over time, internal scale and corrosion would restrict flow, leading to overheating, warped heads, and even complete shutdowns in warmer climates. One of the most notorious issues was the crankshaft pulley breaking loose. The early design used a taper fit with a keyway that could shear or come loose, causing the pulley to wobble, damage the crankshaft nose, or disable the water pump and alternator completely. This problem often occurred without much warning and was expensive to repair. To make matters worse, access to key components was tight. Changing zincs, belts, or mounts often required dismantling half the engine compartment. Today, many boat owners with a 3QM30 on board choose to repower rather than risk continued failures. The Crusader 305 was a small block V8 marinized from the GM 5.0-litre engine. While its bigger brother, the 350, earned a reputation for reliability and solid performance, the 305 often left owners frustrated. It was commonly used in mid-sized runabouts and cabin cruisers, but was underpowered for its size and lacked the torque needed to move heavier boats efficiently. Despite producing around 220 HP, it struggled under load and burned more fuel than it should have. One of the major flaws was its thin-walled casting, which made it more prone to overheating and cracking under marine stress. Head gasket failures were more common than with the 350, and once it overheated, restoring compression was rarely successful without a full rebuild. The stock 2-barrel carburetor also ran lean under load, causing detonation and engine knock. Ignition problems were frequent due to weak electronic distributors used during this period. Mechanics often replaced them with aftermarket kits just to keep the engine running reliably. Many boaters who owned 305s eventually repowered with 350s and never looked back. The Ford Lehman Super 135 was supposed to be the more powerful successor to the beloved Lehman 120, built on the same 6.2-liter Ford industrial base. It added a turbocharger and minor fuel adjustments to push output to 135 horsepower. But that extra power came at a steep cost. The engine became far less reliable. The added turbo boost pushed internal pressures beyond what the non-crossflow cylinder head could consistently handle. The result? Cracked pistons, blown head gaskets, and ringland failures became disturbingly common. Many of these engines developed severe blow-by after just a few hundred hours of hard use. The head, not designed for the extra heat, also suffered warping under sustained cruising loads, especially when operated in warm saltwater conditions. Worse yet, the Super 135's turbo system was poorly cooled, and failure of the oil lines often led to sudden turbo seizure or oil starvation. Owners frequently ended up detuning the engine or swapping it for the older 120 to avoid repeat failures. It was a classic case of more power, less life. The Cummins VT903M was a massive 903 cubic inch, 14.8-liter V8 diesel, originally designed for military vehicles and trucks. When marinized for boats, it seemed like a torque monster on paper, pushing up to 400 horsepower in some configurations. But in real-world marine use, the VT903M proved to be overcomplicated, inefficient, and failure-prone. The engine suffered from excessive camshaft wear, especially on the earlier flat tappet versions. Oiling passages weren't optimized for marine duty cycles, and many owners found metal shavings in the oil pan long before expected service intervals. Head gasket failures were also frequent, particularly in high-output setups with poor cooling loop design. The engine ran hot, and in twin installations it was often impossible to access the rear of either block for service. Even more frustrating was its fuel consumption, burning up to 30 gallons per hour at cruising speed. Many operators switched to more efficient inline sixes like the Cummins N855 or later QSM models. Today, mechanics view the VT903M as an industrial brute that never really belonged in a boat. The Ilmor MV8 5.7-liter was introduced as a high-performance inboard engine aimed at the wakeboarding and ski boat market. Based on GM's small block LS architecture, it should have been a winner, but Ilmor's early marinization of the platform came with serious flaws. One of the biggest issues was the engine control module, ECM, and associated throttle-by-wire system, which were prone to failure due to water intrusion in connectors. When it happened, boats would suddenly lose power, enter limp mode, or fail to start altogether. The exhaust manifold design was another weak point. In saltwater use, these manifolds corroded from the inside out. Flaking rust particles would clog the cooling system, leading to overheating and shutdowns, sometimes with no warning. While Ilmor later improved these components, the early MV8s left a trail of warranty claims and frustrated owners. Some models suffered from oil pressure fluctuations due to poor sensor grounding. Mechanics often had to chase down multiple electrical gremlins at once. Many owners opted to repower with PCM or Yanmar alternatives after repeated failures. The Volvo Penta version of the 2003 series was a tiny 18-horsepower inboard diesel installed in many smaller sailboats and coastal cruisers during the mid-1980s. Though Volvo generally has a strong marine reputation, the 2003 gained notoriety among owners for being underpowered, unreliable to start, and prone to premature cylinder and injector wear. Reports suggest these engines struggled even in light hulls, and overheating was a frequent issue. On several forums, including Sailboat Owners Forum, users recount experiences like burning a quart of oil in just 4 hours, persistent hard starts, and significant cooling flow blockages from corroded heat exchangers or exhaust elbows. One owner described a scored cylinder wall from overheating due to a stuck injector, leading to complete engine removal. Repairing a 2003 today is a pain. Parts have become scarce, and Volvo support is limited for this model. Replacement often means going off-brand or repowering entirely. Mechanics interviewed by owners recall multiple failures in early installations, consistent with user complaints of smoke, overheating, and premature engine wear. It's widely considered one of Volvo's least reliable marine engines ever made. The Pearson-branded Yanmar 2GM20 was a two-cylinder 18-horsepower marine diesel installed as standard in thousands of small production sailboats throughout the 1970s and 1980s. While compact and economical, it quickly earned a reputation for poor cooling performance. The heat exchanger and exhaust elbow often clogged with scale and corrosion, causing repeated overheating and cracked cylinder heads. Owners reported cracked cylinder liners and scored crankshaft bearings resulting from coolant seepage and poor oil cooling circulation. Issues exacerbated by the minimal engine-to-hull ventilation in lightweight sailboat installs. The two-cylinder layout also meant significant vibration at steady RPMs, which loosened mounts, exhaust elbow connections, and raw water hoses over time. Part availability declined sharply after Pearson exited the sailing market in the 1990s. While Yanmar still supports some parts, the exhaust elbow, fan housing, and rear flange components often cost more than the engine's value. Many owners opted to repower with later 3GM or 3YM series engines for reliability and parts access. That's our list of the 15 worst engines ever put in production boats. If you've dealt with one of these nightmares or dodged a bullet, let us know in the comments. We've got more real-world breakdowns, buyer guides, and behind-the-scenes engine truths coming every week. Hit subscribe, give it a like, and thanks for watching. Stay smart, stay safe, and keep your bilge dry.